Hello, and welcome to another edition of Beard Science. Today we're going to talk about electricity and magnets. Now you might be asking why these two together. Well, in 1865, a scientist named James Maxwell discovered that electrical and magnetic fields travel through the air in waves. In fact, he came to coin the term the electromagnetic field or the electromagnetic force, which is one of the four universal forces of nature. Let's take a look. Now, I have some magnets here, and magnets, as you know, have a north and a south pole. If we try to place a north and a north together, or south and a south, you can see that it actually does repel. If we try to do the same, it comes this way. But if we try to take a south and a north, or a north and a south, and you'll see that they will be attracted to each other. Magnets. Now, electricity doesn't have a north and a south, but it does have protons and electrons, and they operate very similar to the south and the north pole. If we have two protons or two electrons close to each other, they will repel. So likes will repel. If we have a proton and electron and a proton, those are opposites and they will attract. You know, my mother always told me opposites attract. So, electricity and magnetism are always present together. Here's an experiment you can actually do at home. It's actually quite easy. I happen to have here, you're going to need three things to do this. We're going to make what's called a homopolar motor, and you're going to need three things. One is your standard AA battery. You're going to need 2 or 3 round, fairly strong magnets, and you're going to need a piece of wire, which I'll show you in a second. So, we take the magnets and we place them on the negative terminal, the flat side, place it onto the table with the top side up. Now, right now, we do not have a complete circle or a circuit. We need to complete that circuit to get those electrons flowing, and the way we're going to do that is this copper wire, which is highly conductive. It is going to complete that circle or that circuit, and let's take a look at what happens. That wasn't good. Let's try again. We've created a motor. Cool. So why does it spin? The magnet at the bottom creates a magnetic field that has a positive and a negative end. The magnetic field is pushing up towards the battery, and the electric flow is pushing down towards the magnet, and these opposing forces cause an outward motion of the wire to spin. Okay. In that last experiment, we used a magnet to create the flow of electricity. But can we use electricity to create a magnet? Of course we can. Here's one you can try at home. Okay, we only need a few items for this. We do need a battery. In this case, I have a AA. We need a nail, and I've taken this nail and I've wrapped a copper wire about 12 to 15 times around this nail. And you can see we still have an open circuit. We do not have that complete circle as it's open here. Now, I'm going to rest this on the battery, and I'll tell you why in just a second. And we're going to see if we can use electricity to create a magnet. As you can see, this is currently non-magnetic and in no way picking up these paper clips. But let's rest it on here very carefully. Now, I was using wire which was not insulated, which meant as the electricity passed through the copper wires, it got very hot. This is called resistance. Make sure you use wires with insulation. So here you can see we've completed that circuit, and we have used our copper wires and our battery to create an electromagnet. Yes. What's happening? Well, the atoms in the magnets are all lined up in the same way. This is not true for the iron, which the nail is made out of. But when we run that electrical charge through those copper wires, it actually aligns the atoms inside the nail, and it acts very much like a bar magnet. Now, electromagnets will only work as long as electricity is flowing.